Hello, everyone. Good afternoon. My name is Hin Lam alongside Gleb Martinenko. Welcome to our presentation on driving telco innovation, distilling large models into economical small language models. We're going to kind of explore the intersection of AI and telecommunication, go into how we can harness the power of language models into smaller models, and we did that by distilling GPT-4. But we'll get started. So on the agenda for today, we'll do a brief team introduction followed by a detailed description of our use case. We'll then explore our methods and results of GPT-4 distillation, and then how we successfully productionalize our solution. And finally, Gleb will conclude with some key takeaways. So I guess for introductions, Gleb and I are part of the Chief Data Office at AT&T. I am a Senior Specialist Data Scientist, and I've been at the company for 2 years. I work with implementing advanced LLM techniques at an enterprise level to drive innovation with Ask AT&T.
Hello. Yeah, hi guys. My name is Gleb Martinenko, and I'm working with AT&T more than two and a half years. I do a variety of different things like big data, DevOps, software engineering, data science, so all in once.
All right, so let's go into our use case overview. So AT&T receives 5 million calls annually. These customer agent interactions are recorded, transcribed, and summarized. We have 2 levels of engagement with these summaries. So the first is early conversation insights. We want to capture themes or issues and anticipate potential needs before they become significant problems. So by identifying patterns early on, we can implement strategies to address them proactively and quickly. Some examples of this, product, pain points, agent, actions, resolution effectiveness, customer sentiment. The next level of engagement is deeper value extraction, which digs into the specifics and nuances of the summary to uncover rich, detailed insights. These insights become features in our propensity to churn models downstream. So effectively, these deeper level insights are just multi-label classification of 80 plus categories. That entails customer service and support issues. So some examples are, did the customer complain about poor performance? Do they need to reschedule their appointment? Are they moving and they need assistance? So now that we have a clear understanding of the use case, let's examine the success factors. So what were what was good about the existing solution? What were some limitations of that solution? How did we solution the challenges, and how did we implement it at an enterprise level? So our biggest success factor is that GPT-4 produced pretty quality outputs, and we were able to save 50,000 customers annually. The challenges there was it was getting really expensive. I believe it took around 15 hours to process 1 day's worth of categorizations. We couldn't scale this solution up if we wanted to. And because OpenAI, it's not in our subscription, we have some privacy and security issues. And if we wanted to add more categories, we effectively couldn't do it well. So our solution was to distill GPT-4 into 3 smaller fine-tuned open source models. And lastly, we'll discuss how we implemented it at an enterprise level. So like I mentioned, we have a multi-label classification of 80 categories. Our first model, we use a fine-tuned classifier. These models are very small and they're quick, about below 100 million parameters. And of the 80 categories, we were able to solve 50 of those categories with this fine-tuned classifier. An example is, did the customer mention competitor name? Our next solution for the remaining 30, we use a fine-tuned small language model. This is H2O's foundational model called Danube 1.8 billion. We use LLM Studio, which is a product of H2O, to fine-tune the model. This model actually was able to capture 20 of the categories. An example of that is customer's scheduled technician needed or never showed up. The remaining 10 questions, we opted to use an open source large language model, and those models are over 70 billion parameters. This one, we used Llama 3.170B. An example of the categories for that one is customer complaints about coverage issues. Okay, so how did our solution actually do? This chart illustrates the accuracy of GPT-4, our 3 models, and an ensemble that represents the average performance of those 3 models. So in our multi-label classification task on 80 categories, Llama produced or did 74% accuracy. The fine-tuned Danube model was 65% accurate, and the fine-tuned classifier was 82% accurate. However, if we took 10 questions, 10 categories from Llama, and we took 20 categories from Danube, and 50 categories from our fine-tuned classifier, we actually were able to get 91% accuracy, which is very close to OpenAI's. Since GPT-4 was the established solution at the time of this evaluation, we used it as the benchmark standard, assuming it to be 100% accurate. So as you can see, each model performs reasonably well on its own, but their combined performance in that ensemble model achieved accuracy that is comparable to GPT-4. Similarly, if we take the GPT-4 cost as 100%, our open source model did about, can't see that, 42%. Danube was 10% in our fine-tuned classifier. But because we took 10 questions from Llama, 20 questions from Danube, and 50 questions from the classifier, we achieved 35% cost relative to OpenAI. And now I'll pass over to Glib for how we implement the solution.
Yeah, so the actual implementation, initially when we start to work on the project, so the actual implementation was very easy. We just have the Snowflake database as our data source. We had the Databricks notebook, and this Databricks notebooks was connected to the Azure AI services. And this approach is very straightforward, but probably it's not a good solution when you have some large-scale projects. Because let's talk a little bit about Azure AI services itself. As a service, it has some advantages and disadvantages, and here is a couple of them. So security, by default, Azure AI provides the good enterprise level of security, like battery low, I'm sorry. Hello? Yeah. So such as encryptions, threat detection, and so on. And in case of accuracy, yeah, as you guys know, probably you keep your proprietary model on Azure services, and of course it's kind of like the golden standard for now, at least for now, for LLMs. And of course, because it's Azure services, it's integrated with all other Azures very easily. But what about the disadvantages? And let me talk a little bit about cost and scalability, because it's two things tied together, right? You can scale your AI services using two types of the models, or pay-as-you-go or PTU, which is provisioning throughput. And of course, for production, you probably would like to have the PTU. But the problem with PTU that you reserve your capacity, and if you're using the batch job, not a streaming job, you pay for capacity when your batch job is finished. So let's assume your job is running like 6 hours and you're done. Another whatever 18 hours, you just pay for nothing. So it's not cost effective. Limited customization of AI, Azure AI services, yes, because it's a PaaS, platform as a service, you cannot customize anything if you want. And troubleshooting. It's very difficult to troubleshoot anything like which is kind of like the black box for you. So yes, it has some metrics which you can look to monitor, but if you want to need really like troubleshoot the things, you need to build the entire solution, which include additional Azure services, additional layers, and additional cost. So how we solve this problem? So we still have the same concept. We have a Snowflake and we have a Databricks workspace. But now, instead of one notebook, we have 5 notebooks. So the input notebook, it's pretty much straightforward. It's do the aggregation, filtering, and everything what we need to prepare data for payload. And then we have 3 notebooks, one for each model. And we're passing whole data set from the input to each of this model. So, but because our model, we know that our model, for example, has good performance with subset of the categories, the model itself kind of like filter the data and sending the data to their AKS GPU node cluster. So this is very important when we're sending not like all 80 categories to the model, we're sending only the categories which require for this particular model. And yeah, we have AKS, we have models which are running on AKS, and this is GPU AKS clusters. And when we finish, when all the models are finished, we combine all the outputs into the last notebook. We do the filtering and validation and saving data to the target data point. So a couple of things again. So design is very important because this model and sharing, when you share the categories between models, it's very huge improvement. And for after scaling, we use Kubernetes and we use horizontal pod after scaling, but because our models is using GPU, there is no metrics from Kubernetes which you can track the GPU load. And when the model is running, it usually do not consume CPU and memory. That's why we implemented the custom metrics, which track the numbers of requests per endpoint and increase the number of instances of the model. So let's say we're sending more requests to Llama, we increase Llama till 10 or whatever, 20 instances. And architecture, yeah, that's simple. We just start to work with the Databricks because Databricks has all like connections to the target and the source, and we use the Databricks workflow. But the code itself is not related to any Databricks or Spark things, so you can run this anywhere. You can run this on a Docker container. And CI/CD again, so many solutions for CI/CD, but because it's Databricks, we're using Databricks Asset Bundle to have all our codes and environment in one place, so we can control everything like parameters, cluster configuration, notification, permissions, all in once. So, and once we implement all these things, we starting to compare with the previous solution. And one of the difference, I mean, the big difference is the time consuming, right? So we were able to deliver the job not in 15 hours, but 4.5 hours. Right now, we're using 3 models instead of 1, and because we created this workflow, if tomorrow, for example, new model will perform better and or provide some more accuracy, for us it will be very easy to embed this model into our workflow. And very important that we able to increase the transcript which is processed. Initially it was 45,000, right now it's 250,000. So we save time, we increase the transcript, and we save money. Yeah. And overall, this is our like big numbers, which we achieved together with Hen and the team. So that's pretty much it. Thank you.
Thank you.
Any questions so we get our next panelist ready?
Sure.
Why you needed to use 3 models for categorization?
Yeah, so yeah, in one of the, I guess the last slide that I went over, if we only use one model for all 80 categories, it just didn't perform as well accurately as 100% for GPT-4. But by doing an ensemble of maybe the easier questions go to a classifier, the medium difficulty questions go to the smaller language model, and then the most difficult questions go to the large language model, we were able to get close to OpenAI's performance. Yes.
we are scaling by number of requests which we are sending to the endpoint. So when you're sending the data, you're sending like through the async call, and you're sending in a batch, and the metrics just track. Okay, if we hit limit like 1,000 requests, for example, okay, we speed up the new instance of the model, and also I forget to mention, guys, we save this money just because, I mean, not just because of that, but also we are paying only for the GPU, which we are only for the hardware, right? We are not paying for the tokens. We are not paying for API calls. We just pay for the hardware. And once the job is finished, okay, we shut down the hardware and we don't pay for that. So the scaling is going through the like number of requests which you're sending. And in HPA, we have max number of pods, like 10, 25. And yeah, but we did a lot of experiments, to be honest with you, to understand how it will perform for us. Each model is a separate. It just separate node space. So it's completely different. So we are sending to the, okay, it's a different endpoint, let's say, okay? And underneath it's a different hardware. Yeah, yeah. We are not decided which hardware. We just, I mean, I think we use 800, right? We use 800 machine, and we understand like I mean, based on our practical, we understand like, okay, for Llama, we need to have at least 10 instances to fully cover the full job. For smaller model, for example, we need just 2 instances.
So to clarify, every call goes to all 3 models, but if Llama 3 is only doing 10 questions or 10 categories, then it'll only inference on those 10. But same call goes to all the models.
Okay, you do the classification, you get all the insights, how is transforming action in the business side. Final question, what is the next step of this project?
So we have a different business unit that takes the outputs of these 80 categories, and they are features in their propensity to churn models downstream. That's how we can kind of, using the test validation, we know that we save 50,000 customers annually. I didn't catch your second question.
What is the next step?
Oh, the next step. Yeah, so we're always working on improving these categories. Sometimes we want to add more questions or more categories. If there are certain categories that we don't have lift to prevent churn, then we'll remove those categories. So it's iterative.